Welcome to Systems and Cloud Administration. This is Lab 3. In this lab, we'll go through Bash scripting and how to redirect commands, outputs, inputs, and errors, how to do piping, and just do a little bit of basic Bash scripting and how to go through conditional statements and for loops, and finally we'll conclude with environment variables. Okay, so the setup for this lab is we assume that you're logging into a bash shell. That's your default shell on most systems, and you also need a text editor that can be nano or vi. Okay, whatever you're comfortable with, you can use for this lab. Okay, so we've talked about redirection in the lectures, and it's a way and mechanism to redirect the channels on any process on your operating systems. Okay, these can be output channels or input channels or error channels. Okay, so we can redirect the standard out from the screen into a file, for example, or the standard input from the keyboard into, for example, a file. Okay, similarly for the error and standard error. Okay, we'll also use piping to communicate between processes. Okay, to connect the standard output of one command into the standard input of another command. The commands that we will use in this lab are grep to search for text, okay, word counts to count words, characters, okay, or lines, curl to download and send an HTTP request, disk usage or DU to find the disk space usage of a given directory, history to look up at the commands history that you have executed since you logged into the system. Okay, so just a note, if your date time is incorrect, then you need to sync it with a tool like NTDPD. Okay, so if I check the time, okay, it seems to be correct on this machine. Okay, so the exercise, we start with exercise 1, redirection. So use the DU tool to find the disk usage of each file at var log. Okay, use the -h option to show the size information in human readable formats. Okay, so du -h and then give it the directory variable log. Okay, hit enter, and now we can see that it gave us the directory to some directories. Okay, some nested directory you weren't able to see because the permission is restricted to root users. Okay, if I want to see all the directories, I can prefix the command with sudo and then hit enter, type the root password, and now I get all the results, the size of each directory. Okay, so this is the du command. Okay, so now it says rerun the command, okay, and redirect the output into a file named log size. Okay, so the same command, instead of seeing the output on the screen, we can redirect that into a file called log size.txt. Okay, enter. Now if I open that file, we can see that it contains the output of that command. So we redirected the std out in this case. Okay, next is it says rerun the command and redirect the errors, only errors to error.log. Okay, so if you remember, errors can be redirected using just number 2, and then you put the greater than sign. Okay, so to redirect errors, okay, the same command. Okay, probably if I run the command without sudo, okay, you can see that it will produce sorry, without sudo. Okay, if I run the command without sudo, we'll see that it will show an error, and so that's an error here, permission denied, and output. Okay, so if I want to see only, okay, only the output and the error to go into a file, okay, then I do to and then name it error.log. Okay, hit enter. Okay, now we only see the output, but the error went into a log file. Okay, so the fourth step here is to rerun the command and redirect errors into a file named error.log and output into log size.txt. Okay, so if I remove both files, okay, by the way, you don't need to remove them because once you overwrite them, basically the content of the previous state of the file will go away, and then you'll get the new content. Okay, so if I run the same command, okay, redirect the errors into error.log and then rewrite the output into log size.txt. Okay, and then hit enter. So now we can see log size has only the output, and then the error has only the error. Okay, so that's for redirection. Okay, so the last one in redirection is to save the history of the previously executed commands. Okay, for that we use the history command. Okay, just redirect the output into mycommands.txt. Okay, so the history command will show all the commands that you have executed since you logged in, so 66 commands in this in my case. So if I go into history and then redirect that into a file, my commands.txt, enter. Okay, so now we move into the second exercise with pipes. Okay, how to redirect the std out of one command into the std in of another command. Okay, so let's say I want to count how many programs in root bin. Okay, usually we use ls, but if you see ls, then you get a long list of programs. Okay, obviously we don't want to count that manually, so there is a command for that. Okay, so you do ls and then pipe that to wc -l, and here I get the total number of commands or files in that directory, which is 665. Alright, so the last one is to use curl, okay, with the command line -h to read the help, okay, manual of this command, and to search for the command line option that can be used to include the headers. Okay, so curl is a command line tool to send and transfer data from or to a server. Okay, for example over HTTP. Okay, so we can look at the content of a web page. Okay, and then we do example.com, for example, to curl, and that way we can see the actual content of that page. Okay, if we try to send an HTTP GET request and we want to see the headers, then we probably need to use a command line option, okay, for that, because as you see, curl only outputs the content of the HTML page, okay, without the HTTP headers. Okay, so we could look at the manuals, okay, but the fastest way probably is to use -h. Okay, but as you see, it will throw all the command line options. Okay, so it's hard to skim through these options. Okay, so the way to do it is basically to grep. Okay, so pipe the output of curl -h into grep. Okay, and then put the keyword to search for. Okay, in our case it's headers. Okay, so now we can see the command line option is -i to include the headers. Okay, so if I do -i before the HTTP address, then I hit enter. Then now we should see the actual header of the page. So you can see the http://1.1200 the status code, which means okay. So that's how you do pipe and pass the output of the command into the stdin of grep. Okay, so now we move into bash scripting. And the first exercise is to create a simple script, that creates a unique file. We know the command to create a file is called touch, or you can use a text editor for that, nano vim to create a new file. There are many ways to create files in Linux. The easiest one is to use touch command, and give it the name of the file. So it will create an empty file for you, temp.txt in this case. So if I want to create a unique file with timestamp, it says use the date command, with the plus and %s option to get the timestamp, the unique timestamp on this machine. If you want to create a file, with touch and append the name to it, we do the command touch, name the file, for example, underscore, and then if I want to write a command together, append the command to the name, then I do $, and then open the parentheses and type the command, date plus %s, and then let's say .txt. So what will happen here is basically touch will create a file with the name file underscore, and then it will execute date command with the plus %s to get the timestamp. The output of this whole thing between the parentheses and the $, is basically going to be appended into the file underscore name, and then we will add the .txt. So if I hit enter, now I can see the file that has been created. File underscore with the time stamp. So now to put this in a bash script, all you do is just create a script. You can use vim or you can use nano to create the script file. So let's call it create unique file.sh. And then start writing your script. When bash the program, the script should run on, and then we type the command that we just did. Touch file underscore, and then percentage date, $, and then parentheses date, and then plus %s dot txt. So this is what your bash script should look like. And then you save it. To save it, you do a nano control X, and then you hit yes, enter, and now save and exit. So if I want to run the script, if I try to run the script, that I just called create a unique file, we have to add the permission, the executable permissions, with change mode, for only the user, give it the execute permission, and give it create unique file, hit enter, and now you should be able to create the script, run it 3 times, and you should see files that ends with time stamp. So this is how you create the script. You change the permission, and then you run it. So now is the next exercise is to run a remote script. So suppose that we have a remote script that we want to download, from a remote server, and then execute the script. So there are 2 ways to do it. You can just curl the script, get the actual content of the script, and then pipe it into bash. So curl https, and then type the actual URL, CPIT-490 examples raw master and then bash scripts and then hello.sh. okay, so this is the actual content, okay, of the script. So you can see it executes hello and then who am I, okay, date, and then system has been running, uptime to execute the uptime command, and then which will show you the last login, okay, how long the system has been running, and then the last login of the system on the system, and then it will tell you your present working directory, and then it will print done, okay. So this is the content of the script. To run it, you can just pipe the output of curl into bash dash, okay. So run it. So now it's being downloaded and then now it's running, okay. So you can see that we downloaded the content and then we passed that output into bash, okay. Obviously this is considered a bad idea, okay, because you don't want to download untrusted script and run it on your machine, okay. What if there is rm, okay, commands to delete your local home directory, okay, or other important files to you, okay, do some other crazy things, okay. So you shouldn't do that unless you know what you're doing, okay, and know the content of that file, okay. So you could alternatively you could download the file, okay, into your system, okay. To do that you use curl with the minus O capital, okay, and then now you can do ls for hello, okay, sh. Now you can see it. To execute it you need to give it the executable permission for only the user, okay, that's what you usually do. And then to run it, you run it the same way you run your script, okay, but make sure you always read the content of the script, okay. Open it in your text editor and make sure that you read the script carefully before you execute it, okay. So that's it for installing and downloading remote scripts. Okay, so now we move into conditional execution in shell script, okay. So each command in shell in the shell returns an exit code, okay. So if you run ls and it runs successfully, it returns a number, okay, that's called the exit code, okay. If the exit code is 0, that means the command is successful, okay. If it is anything other than 0, it means the command produced an error or failed to execute, okay. So if I want to check the exit code for a command, there is a variable called question mark, okay. So we know that we can print any variable, remember, any environment variable like path, okay. We used to print path with the $sign, okay. So there's an environment variable called question mark, and that holds the exit code for each command, okay. So if I do echo $sign question mark, it tells me 0. That means the last command that I executed, which was ls in my case, returns 0. If I do ls to any file that doesn't exist, okay, it results in an error, okay. If I print the exit code for that command, it returns 2. That means the previous command, the last command that you executed, failed to execute, okay. So sometimes I want to execute a sequence, a commands in sequence, okay. I want to execute commands in sequence, so I want to ensure that all of them succeed in order, okay. So sometimes, for example, I want to execute the first command, and then once it was successful, I want to execute the second command, okay. So to do that, we use the and symbol, okay. So the and symbol relies on the exit code for each command, okay. So if this command right here returns 0, then it means it's successful. Okay, so we can pass on and execute the second command. Okay, if this command returns any number, the exit code any number other than 0, that means it failed, so it will not execute the second command. Okay, so if I do this, ls to bin, okay, and then and cd to bin. Okay, I don't have a bin directory, so that command will not execute. Okay, so we did not go into that directory. Okay, but if I have that directory, okay, make directory and bin, then if I run the command ls set will be successful, then I will go into that directory. Okay, so now it worked. Okay, but as you see here, when I did ls to a directory that doesn't exist, okay, so temp, for example, in my home directory, and then change into temp. Okay, so the only command that failed in this case is temp. Okay, is ls. Okay, so ls is the only command that failed in this case, not the cd command. Okay, so you only see one error message. Okay, if I put a semicolon, okay, we will get 2 errors. Okay, because 2 commands were executed. Okay, so the and here ensures that the second command, which is right here, it will only be executed when the first command returns 0. Okay, remember 0 means successful. Okay, so that was for conditional execution. Alright, so now we move into conditional statements. Okay, so conditional statements in bash. Okay, so I want you to download a shell script. Okay, if you look at the shell script content, it's basically a script that checks for IP version 4 connectivity. Okay, so it will send a ping request to some IP address and to something we called a black hole. Okay, a special file that will be discarded. Okay, any content that you throw here will be discarded immediately. Okay, so we check the content of that files. Okay, and then we execute the commands in this file. Okay, so to download the file we use curl. Okay, so remember we've used curl previously to download files, so curl -o https gitlab.com CPIT-490 examples row, and then master branch, and then bash dash scripts, and then f dash statements.sh. Okay, so downloaded that script. Okay, we can look at the content of that script. Okay, so this is the content. Okay, remember you have to look at the content of any script you download before you execute it. Okay, so it will print an echo message. The script checks for IP version 4 connectivity, and then it will send a ping to -C1. It means only one attempt. Okay, -Q for quiet output, so don't print too much things. -W for timeout after 2 seconds. Okay, 1.1.1.1 is an IP address for a DNS provider. Okay, and then the output, we're doing a redirection to div null. This is a special file in the operating system. It's often called black hole. Okay, anything that you throw there, it will be discarded. Okay, so you will not see the file created. Okay, and then we have a variable called return value. Okay, this variable will hold basically the exit code for the previous command. Okay, so $? means the exit code of the previous command, which is the ping command. Okay, and then we check the value. If it is equal 0, it means successful. Okay, we assume the network is up. Anything else it means the network is down. Okay, remember to run the script, we change mode, okay, to the user plus X to if dash statements, and then run the script, okay, using if dash statements. Okay, so now we need to ask the user for confirmation on whether he would like to check again and save the output of ping into a file. Okay, so basically yes or no question, and based on that whether we run the script or not. Okay, alright, so if I go and ahead and open that script in text editor, okay, go to the bottom of the file, and then basically we need to ask the user for confirmation. Okay, so would you like to rerun the script and save the output into a file? Okay, and then we ask them yes or no. Okay, so that's how you put this confirmation message. Okay, and then if to read the user input, the answer, we use the command read. Okay, and we give it the name of the variable. Okay, so let's say response. Okay, resp. Okay, so next we check for the value of that variable resp. Okay, so resp. Okay, and then we say equals y for yes, semicolon, then, and then we say, we basically run the same command, ping, just one time in quiet mode, and timeout is 2 seconds, 111. Okay, and then we output to current working directory, let's name it network status. Okay, so this is how you run and pipe, or sorry, redirect the output into a file called network status and .txt. Okay, and then we end the if statement with fi. Okay, and then save the file. Okay, so the file name is if statements. Okay, .sh, run it, and then now it asks me whether to rerun it again, and I say yes. Okay, so there's a mistake in my script. Let me just type on line 13. Okay, so probably a space, and then save it. Yes, run it. Yes, and now I can do the cat to network status. So now we can see the output of that. So that's how you do if statements and read the input from the user. Okay, so the fifth exercise is to work on for loops. Okay, so I have a program here that aims to loop through the list of directories in root home. Okay, so any user home directory in the system, and for each user home directory, run this command du or disk usage -h for human readable format, -d for the depth, 0, and then to that directory. Okay, so we'll only see or get the size of the user home directory. Okay, no other subdirectories, and then done. Okay, so this is actually fairly simple. Okay, so only need to put user home star here and loop through for each user directory here. So let me just show you how this example should look like. Okay, so you have for statement. Okay, the for loop statement, you put for user dir in home star, do the following, the same command, which should give you the size of each user directory. Okay, so if I exit, and obviously you need to change mode user plus x to the for loop. Okay, example. Okay, and then run it with for loop. Okay. So it seems like we got the permission denied because we're trying to look into a home directory of another user. So that means we need to run it with sudo. Okay, so run it as a root, and now you can see the size of each directory. Okay, so that's how you do how you deal with for loops, okay, in bash. Alright, so the last exercise is on environment variables. Okay, so it asks you to rename the script in step 4. Okay, if statements. Okay, the script that checks for internet connectivity into check network.sh and add that into a directory called bin, okay, under your home directory. Okay, so to do that, I can do it just in one command. Okay, so make directory first for bin, okay, because I'm in my home directory. Okay, if you're not under your home directory, you can do it with tilde or /bin. Okay, so it already exists in my case. Okay, so if it already exists, let me see. So it exists, but it's empty in my case. Okay, so that's something probably created previously. So now we need to move the file, okay, from if statements, rename it, and move it at the same time. Bin, and name, the new name is check-network.sh. Okay, so clear the screen. So now I want to do or call the script from anywhere, any present working directory. Okay, so if I'm at home, I know the script is not, the check network is inside bin. Okay, so instead of calling it with bin check network.sh, I want to call it just by its name. Okay, I will get command not found, because whenever you type a command, the shell will basically lock inside your path environment variable. Okay, that path environment variable is defined inside a file. Okay, so if I open the file, okay, under my home directory .bash profile _profile, okay, and go to it, you see this is where you're telling it whenever to type a command, go look inside this directory. Okay, so inside your home .local bin. Okay, that's what is being defined here. Okay, so if I go and append something like my home directory, you can use the environment variable home and then /bin. Okay, so if I don't want to use home, I could just use tilde as a simple and it should work. Okay, but I prefer to use environment variables. Okay, home is defined somewhere in a file as an environment variable. Okay, so this will append that directory into the path. Okay, this will not take effect until you reload it, okay, or log out and then log in again. But you could just use the command source to reload it. So now if you type the same command that we got, command not found, it will work. Okay, so the script worked. Let me just kill it with Ctrl+C. Okay, if I go to etc, okay, now I can also run the script and it should work. Okay, so let me just hit no. Okay, so this is how you use environment variables to add commands or tools that you downloaded and call them just by their names. Okay, so that's it for lab 3. Hope you learned about bash scripting and conditional executions and environment variables. Okay, so that's it for lab 3. Okay, we'll see you in the next lab.